Homework help session on thermal physics. This is question number 11 on Weber sign, which is the density of gas atoms at a certain location in the space above our planet is 4.90 times 10 to the 11 per meter cube. The pressure is this much. What is the temperature there? Since it talks about gas and pressure, volume and temperature, what is the equation that we know describes ideal gas behavior? PV equals nRT. So we know the pressure and we know universal gas constant. We want to know the temperature. We don't know the number of moles and we don't know the volume. We look at density of gas and its unit. It is 4.90 times 10 to the 11 per meter cube, which means we could take this to specify the number of moles per meter cube, and therefore you have N divided by V given to you as this. And so if you know all of that, can you solve for the temperature? And then on the next question it says a lead bullet is traveling at a certain speed and strikes a target, and all its kinetic energy is converted to thermal energy. You have its initial temperature and the specific heat and the latent heat of fusion and its melting point. So the piece of lead is at 40 degrees Celsius. It's not going to melt at 40 degrees Celsius. So if you want to melt lead, you first have to increase the temperature from 40 to 327 degrees Celsius. Heat supplied in order to increase the temperature of a substance is mc delta T. If you know the mass of the lead, the specific heat capacity, and the increase in temperature which you want to accomplish, you can calculate this. So now that you have got the lead piece at 327, it's not going to start melting on its own, so you have to supply heat in order to melt it. The heat supplied to melt the substance is mass times latent heat of fusion. You know the mass of the lead and you know the latent heat of fusion, so you find out Q1 and Q2 and the total heat required in order to take the lead from 40 to 327 and melt all of it is Q1 plus Q2. On the last question, how much heat is added to 11 grams of ice at negative 20 to convert it to steam at 120.5? So again, recall that if you want to change the temperature of a substance, heat supply needs to be mass times specific heat times the change in temperature. If you want to change the state of a substance, then Q equals mass times latent heat. Now the ice is at negative 20. So you cannot melt ice to water at negative 20. So the first thing to do is to take the ice from negative 20 to 0 degrees Celsius. So you got the heat, and then now it's ice, so you need specific heat of ice. So you can find out how much heat is required in order to increase the temperature of 11 grams of ice using the specific heat of ice. Then once it's at 0 degrees Celsius, you got to melt ice to water at this temperature. For that, you need to calculate how much heat is required using this formula, because latent heat tells you the amount of heat required to melt ice. Well, then this melted ice is still at 0 degrees Celsius. So it's now water. So from water at 0, you need to take it to 100 degrees Celsius, because only then you can vaporize it to steam. So again, now you have to do heat supplied in order to increase the temperature of water. So now you use specific heat capacity of water. Well, now that the water is at 100, you can vaporize it into steam. So you have to convert water to steam at this constant temperature of 100 degrees Celsius, which means you need to calculate the heat as mass times the latent heat of vaporization, because this tells you how much heat is required to vaporize water to steam. This steam is now at 100, but you want steam at 120.5, so that means you are going to now increase this temperature of steam from 100 degrees Celsius to 120.5 degrees Celsius. Which means again, you want to use this formula, Q equals mc delta T, because you're changing the temperature and this time you're going to use the specific heat of steam because it's now not water anymore. And so if you want the total heat, you just find the heat for each of these changes and then add them up. So it's basically, you need to understand that if you want to increase the temperature of a substance, you want to use this formula, because the amount of heat that you supply depends on the mass, what type of substance it is, because all substances don't take the same amount of heat to raise their temperature, and how much rise in temperature you want to bring about. If you want to melt or vaporize a substance, then you want to use this formula. The last but one question on the aluminum bowl holding soup is to be approached in the same way. If you keep a bowl full of soup inside the freezer, which it is at 26.6 degrees Celsius. So the first thing that will happen is that the bowl and the soup are going to cool from 26.6 to 0 degrees Celsius. So that's change in temperature, so you can find out how much heat is required. You have this much of heat. So if the heat required is less than this, that means you subtract and you can see, well, you still have some more heat taken away. It's not heat supplied, but it's heat taken away. So you have some more heat that could be taken away. Once these two reach 0 degrees Celsius, what is likely to happen? Your soup is going to freeze. That means it is undergoing a change of state. So you can find out how much temperature, how much heat needs to be taken out of the soup in order to freeze it. And once it freezes, then everything is at 0 degrees Celsius, and now they will start cooling below 0 degrees Celsius. That means again you're taking away heat from this as well as from this.
Good afternoon, Raiders.